and then we move to the next row. So the next row has the number, only one number in it. It's -3, so I do second row times the first column, that's -3 times -5, that's 15. And now you have to think about where you're going to write that. Since you're multiplying with the second row, then you write in the second row of your answer. So -3 times -5 is positive 15, and then you do second row times second column, -3 times 4 is -12. And then this would be your answer. Okay. Now something else that I did not show you yesterday is I want to talk a little bit about when you can multiply and when you can't multiply. If you attempted to do all of your worksheet, you ran across some problems where you could not multiply the matrices together, and that happens with multiplication. Okay. So what I want to talk about is we'll use this one as an example. I'm going to erase the answer. You may still copying the answer? Alright, let me show you something that you can do. So a matrix has rows and columns. So one thing that you can do is you can look at this first matrix and you can decide how many rows it has. So can y'all tell me how many rows the first matrix has? It has 2 rows, and how many columns? 1. So a matrix, sometimes they ask for the dimension of the matrix. Okay, like a rectangle, its dimensions are its length times its width. So sometimes they ask for the dimensions of a matrix, and when they ask for the dimensions, they want the rows first and the columns second. So it goes back to that RC cola thing. It's a 2 by 1. The second matrix has how many rows? 1 row. And sometimes I have to do this. Guys, look, this is a row. This is a row, and this is a column. So the second matrix has 1 row, and how many columns? 2. So the second matrix would have dimensions of 1 by 2. So this is kind of important because if we can multiply, the 2 inside dimensions will be the same number. If we can multiply, the 2 inside dimensions will be the same number, and our answer will have the dimensions that are left over. And so the dimensions that are left over are a 2 and a 2. So our answer will end up having 2 rows and 2 columns. So I erased the answer, but look back at the answer. Does your answer not have 2 rows and 2 columns? So sometimes when we get confused about multiplying matrices, we can actually think about the dimensions and make sure our answer has the correct dimensions. So let's just kind of practice this. So if we were multiplying a 3 by 2 times a 2 by 4, would it be possible to multiply a matrix that has 3 rows and 2 columns times a matrix that has 2 rows and 4 columns? Would that be possible? According to what I just told you, yes, it's possible because the 2 inside dimensions are the same. Okay? And then your answer would have dimensions of 3 by 4. So without really knowing a lot about what you're doing right now, you could look at the dimensions and tell whether you could multiply them together. So the 2 inside numbers have to be the same. So could I multiply a 3 by 1 matrix times a 2 by 3 matrix? I couldn't, because the 2 inside numbers are not the same. And once you understand how to multiply, when you go to start to multiply, you'll realize your numbers don't match up in the rows and the columns. Alright, what about 2 matrices that always have the same dimensions? So like a 2 by 2, could you always multiply it with a 2 by 2? And if I have a 3 by 3, could you always multiply it by another 3 by 3? Yeah, because the 2 inside numbers will always be the same. So sometimes the dimensions are the same, and sometimes they're not, but the 2 inside numbers would have to be the same. So what about when you're adding and you're subtracting? Tell me about the dimensions when you're adding and subtracting. So if this matrix has 2 rows and 3 columns, then what are going to be the dimensions of this matrix that you're either going to add or subtract? Is it going to have the same dimensions?
Yeah.
If you're adding or subtracting, the matrices have to have the same dimensions. If you're multiplying, just the dimensions in the middle have to be the same. All right, let's look at number 3. So number 3, the first matrix has how many rows? 2 rows. How many columns? 2 columns. Y'all get that? 2 rows, 2 columns. The second matrix has how many rows? 2 rows and 2 columns. So should we be able to multiply these together? We should. Okay. So we're going to start with the first row. We always start with the first row, and we multiply it times all of the columns. So first row times the first column is going to give me 2 numbers. And that's why I'm going to have to use parentheses here. What 2 numbers am I going to get when I multiply the first row times the first column? 10. And since it's a negative 15, I'm just going to write minus 15. Then I have another column, so I'll go down to this column. I'm still multiplying by the first row, so I'm still writing my answer in the first row. So first row times second column gives me negative 5 times negative 3, which is positive 15. Negative 5 times positive 5, which is negative 25. You don't have any more columns to multiply by, so then you go back and you pick up the next row. So now I'm going to multiply by the second row. When I'm multiplying by the second row, I write my answers in the second row. Second row times the first column is going to be 2 plus 6. Second row times the second column is going to be 3 plus 10. Put your little brackets back around here and simplify. So you're going to end up with negative 5, negative 10, 8, and 13, unless I made a careless mistake. That will be your answer. All right, let's go down and look at number 8, because number 8 is going to be a problem where I cannot multiply. The directions say simplify, write undefined for expressions that are undefined. So in this situation, undefined means you can't do it. Just like you can't divide by 0. In number 8, they're giving us 2 matrices that we can't multiply together. Okay? It's impossible to multiply them together. When you start to multiply, if you know the process, you're going to understand it just won't work. So the process is take the numbers in the first row and multiply them times the numbers in the first column. And y'all see why that just won't work in number 8. What are the numbers in the first row in the first matrix? 3, 2, and 5. And you're trying to multiply that times the first column in the second matrix, which just has a 4 and a 5. So you don't have enough numbers, okay? You would need another number down here, and so it just doesn't work, okay? So that's going to happen sometimes. If you're not sure, I think you will be if you do enough of these. I think you'll realize that you can't multiply. If you can't multiply, then you'll do the dimensions. So how many rows in the first matrix? How many rows in the first matrix? 2 rows. How many columns? 3. How many rows in the second matrix? 2. How many columns? 3. So are the 2 inside dimensions the same? No. And that's when you won't have enough numbers in your row and your column that won't be the same equal numbers, and you won't be able to multiply. So on this worksheet, if you can't multiply 2 matrices together, they're asking you to write undefined.